thing for this lesson, even and odd functions. This is actually pretty easy. Okay, it's not going to look that way in the beginning, but it'll get there. So just you're all right. Okay. So an even function is a function that the reflection over the y-axis is the same as the original function. So when you take the function and you reflect it over the y-axis, you get exactly what you started with. And you can see how you would get that with this. Okay? So, so I think this is fill in the blank. So you can take a minute and do this. But this is an even function. Okay, so if you need to pause the video to fill in the blanks, that's fine. All right, an odd function is a little harder. An odd function is when your reflection in the y-axis equals your reflection in the x-axis. And it looks like you can take the function and rotate it 180 degrees and it will look the same. So you can take it and you can, okay, so let's pretend that we only have this side. You can flip it over the x-axis so it would look like this. And then you can take that and flip it over the y-axis and you'll get the same thing. That's what a rotation around the origin, or having it's symmetric about the origin, that's what that means. Okay? So when it does that, when the reflection in the y-axis equals the reflection in the x-axis, it's an odd function. All right, so in a nutshell, if f of negative x equals f of x, if the reflection in the y-axis equals the original function, it's even. If the reflection in the y-axis equals the reflection in the x-axis, it's odd. Now, let me tell you an even easier way to remember that. If every term of a function has a variable with an even exponent, this includes the constant if there is one, it will be an even function. If every term of a function has a variable with an odd exponent, it will be an odd function. Okay? So let me show you. Look at this function, x to the third, x to the first. So it's odd. But let's prove it. So I'm going to reflect it over the y-axis. And I'm going to replace, when I replace a negative x into something with an odd degree, remember it changes the sign. So negative x cubed, this is also odd, so that changes the sign. Now I'm going to reflect it over the x-axis. Negative f of x. Well, that's like I'm putting a negative in front of the whole function, so it changes the signs of all the terms. So I have negative x to the third plus 7x. Well, what do you notice? These two are identical. Isn't that what we just said? Shows that it's odd. So you would say f of negative x equals negative f of x. So f of x is odd. We already know that because all we have to do is look at it, but this proves it. Okay, so we come over here and we look. This is a constant, so it's even. Constants are even. So we have x to the fourth, x squared, even. This is even. Let's prove it. We have g to the negative x equals, we plug that in. Remember, if it's even, it doesn't change. So we have x to the fourth plus even, doesn't change, minus 1. We can do this too. Oops, that should be a g. negative g of x. That gives us negative x to the fourth minus x squared plus 1. Okay, what do we notice about this? G of x equals g of negative x. So g of x is even, right? Because these two are the same. All right, finally, what do we notice here? This is odd, this is even, which is the case with most polynomials. So it's going to be neither, right? But we got to prove it. So h of negative x is negative x cubed plus 2, and negative h of x is negative x cubed minus 2. Well, nothing is equal. So h of x is neither. Okay? All right, when you're asked about this on the test, this is the kind of thing they're going to be looking for. All right, well, that takes care of 3.8. Your homework is on big ideas. This is a cool mathy type picture. If you have any questions, you know where I live. Well, I feel like I live here, but you can always come and ask me.